Hi everyone! Today we'll be talking about the Pythagorean Theorem. Remember to write down the learning target. Today's FLT is the following. Given a right triangle with two known side lengths, I will be able to find the missing length using the Pythagorean Theorem. What is the Pythagorean Theorem? Let's take a look. Here we have a right triangle with two legs, A, B, and the hypotenuse, C. According to the Pythagorean theorem, in a right triangle, A squared plus B squared equals C squared. So I tried color coding it. Notice we have the two legs A and B, and the hypotenuse C. In other words, the Pythagorean theorem states that the sum of the squares of the two legs equals the square of the hypotenuse. So today we'll be using the Pythagorean theorem to find the lengths of missing sides. We will use A and B to identify the legs and C to identify the hypotenuse of the right triangles. Here is our first example. So the example asks us to find the missing side length. Let's start off by labeling the sides A, B, and C. We have the two legs. So A equals 2. That's this leg right here. And we also have another leg, B equals 5. That's this leg right here. So we use A and B to label the legs. And lastly, we have the hypotenuse. That's this one right here. We're not sure what the hypotenuse is. This is the missing side length that we have to find. So we're going to use the Pythagorean theorem to find this missing length. We have A squared plus B squared equals C squared. Let's replace A and B with our known values. So 2 squared plus 5 squared equals C squared. And let's start simplifying this. 2 squared equals 4 plus 5 squared, which is 25, equals C squared. And then 4 plus 25 equals 29. So we have 29 equals C squared. I want to isolate C, so I'm almost there, but notice I need to get rid of the square. So to remove the square, I'm going to take the square root on both sides. C equals the square root of 29. And on Delta Math, where you'll be doing practice problems, you'll be either asked to find an exact answer or an approximate answer. This is an exact answer. But let's look at what an approximate answer looks like. So using your calculator, you'll find the square root of 29. And you can use your phone or an online calculator, whatever you feel more comfortable with. You should get something like C equals 5.385, and then it keeps going on. But we're going to round to the nearest tenth. So we're going to round to this digit right here. So we'll look at the number right after it. We have 8. That means we're going to round up. So as an approximate answer, C is approximately 5.4. So the length of the missing side C equals the square root of 29. Or, in other words, approximately 5.4. So be sure to read the problem carefully when you're working on problems on Delta Math, you will be either asked for an exact answer or an approximate answer. Let's look at another example. Regardless of which way the right triangle is facing, the hypotenuse is always the side opposite of the right angle. So with that being said, let's find the legs and let's find the hypotenuse. The lengths of the legs in this example are given. So the two legs, we have A equals 3 and B equals 7. These are the lengths of the two legs. And we're missing the length of C, the hypotenuse. Again, the hypotenuse is the one right across the right angle. Let's use the Pythagorean theorem to find this missing length. We have a squared plus b squared equals c squared. And let's plug in the values we already know. So 3 squared plus 7 squared equals c squared. 3 squared equals 9, and 7 squared equals 49, equals c squared, and 9 plus 49 is 58, so we have 58 equals c squared. Let's take the square root of both sides, so we have c equals the square root of 58. This is our exact answer, but let's find the approximate answer as well using our calculators. We get something like c equals 7.61577, and it just goes on. But we're just going to round to the nearest 10th place. Since the 100th place is 1, we don't have to round up. So C is just 7.6. So C, the hypotenuse, equals the square root of 58, or 7.6, depending on what type of answer you're being asked for. So far, we've looked at examples where we find the missing hypotenuse length, but sometimes you might be given the hypotenuse and one leg, but you have to find the length of the other leg. So let's look at an example like this one, where we have a hypotenuse and a leg, but we're missing the other leg length. So we're missing this leg length. Let's just set this as A, and we also have B equals 3. So again, we're not sure about the length of A, but we know that B equals 3. So these are the legs. And for this example, we're given the hypotenuse. So C equals 5. So we're going to use the Pythagorean theorem to find the length of A. So A squared plus B squared equals C squared. We're not sure what A is, that's what we're solving for, but we know that B is 3, so 3 squared, and C is 5, so 5 squared. Let's start simplifying. We have A squared plus 9 equals 25. And we want to isolate A, so what we're going to do first is subtract 9 from both sides. We're subtracting 9 from both sides because I want to get rid of that plus 9. We're left with A squared equals 25 minus 9, which equals 16. Now let's take the square root. So A equals the square root of 16. 16 is actually a perfect square. The square root of 16 is just 4, because 4 squared equals 16. So for this problem, we just have an exact answer, a equals 4. So the missing length in this case was a leg length, and we found that a equals 4. So for this example, I set a as the unknown, but you'd get the same answer even if you set b as the unknown. Let's look at one more example together. Here we have, let's make this one a, and let's make this one b. So we have a equals 4, but b, the other leg, is unknown. And the hypotenuse length is 10, so c equals 10. So we have to find the missing leg length. Let's use the Pythagorean theorem. A squared plus b squared equals c squared. We know that a equals 4, so we have 4 squared. B is unknown. And c equals 10, so 10 squared. 16 plus b squared equals 100. And I want to isolate b, so I'll subtract 16 from both sides. And remember, you can pause and rewind the video whenever you need to. We're left with b squared equals 100 minus 16, which equals 84. And we take the square root, so b equals the square root of 84. This is not a perfect square, so let's find an approximate answer. Using my calculator, and then I rounded, I got b is around 9.2. Our missing leg length, b, equals the square root of 84, that's our exact answer, or approximately 9.2. Similar to the previous example, you could have instead made a the unknown value, but I figured some variety might be nice. So the Pythagorean theorem states that for any right triangle with legs AB and hypotenuse C, a squared plus b squared equals c squared. Today, we use this Pythagorean theorem to find the missing side length when we were given 2 sides. Great job today, and please remember to submit your notes on Canvas.